So welcome everybody. Welcome to the pitch session, the Shark Tank of Ideas. My name is Gerhard Fettweis. There's Regan Piggott. Regan has been doing all the background work, so thank you very much for having done all this. Without Regan, this wouldn't happen. I'm the moderator. I'm the Director Industry Outreach currently at IEEE ComSoc. My name is, as I say, Gerhard Fettweis. I'm Vodafone Chair Professor at TU Dresden, and I head the Barkhausen Institute, also in Dresden, which is a non-for-profit research institute. We have a couple pitches ready, so that's pretty cool, I think. For those that don't see my small face back here, this is my big face out there. Same glasses, different shirt. That's in the winter time. In the summer, I'm a little dressed differently. It's good we have this pitch session. It is an opportunity for young academics. We already had young academics that were 50 years old. So young academics in an academic sense that have had little challenge, possibility of reaching out to industry collaboration, that have been massaging and twiddling equations, writing software, doing simulations, doing whatever all. And now they say, actually, we think our ideas are so great, we want to reach out. So therefore, we have this as a bridge between academia and industry, or industry and academia. It is for academics to give them a chance to actually pitch an idea where they think this should be interesting for industry, but I just don't have the contacts. And you want to pitch bold spaces. You have to submit your idea in advance. It's not more than a little more than a letter-sized page, 1.5 pages, 2-page idea that you have to write down in a certain way. You submit it. It's evaluated by an evaluation committee, and the top 5 get a chance to pitch. Today we have a top 6, but we have one person, Ehsan, who is still finding his way. He's here. There he is. So we have 6 people, and it's your chance to really give your idea there. We have 6 people because we found out of all the submissions, these 6 to be so good, it was difficult to choose 5 out of them. Therefore, this is it. Now, we're also having, of course, these are the pitchers, those are the sharks, and the sharks are sitting right there, the mean people that are going to ask mean questions. But as I said, every question is about content, not about person, please. We don't become personal, it's about content. And so these can be just questions about understanding the problem. Hopefully that doesn't exist because everybody has read the essay before. To give you an idea, what that means, you have to be able to survive this down selection to those top 6 that are sitting here by really having a bold idea, something that can tickle the interest of industry, and you have to get that going. It's about, as I said, clarity and significance, novelty and vision, relevance and potential, impact. And it is okay to pitch an idea where you say, you know, guys from industry, here's a fantastic idea. I think this is going to be ready for collaboration, but I don't know really about, are my assumptions correct? So it can be that you are looking for the right boundary conditions. It can be that you're looking directly for money, but it also can happen that a company comes to you and says, or a company person comes to you and says, in this case, all men, man, this is something so good, you should start a company. Forget about starting an industry collaboration. Let's fund a project and start a company. Everything is possible here, and we take it as it comes. So what you expect is high impact 5-minute pitch. Yes, if you're a PhD student of mine, you've been through that training. If you're not a PhD student of mine, almost nobody has been through a 5-minute elevator pitch training of your idea. So we'll see how you're going to be doing. I always say to my PhD students, you have 3 slides. What is the problem? What's my approach? And look how much better I am than the competition. So here, this is where we are. See where this takes us. And we also, as I say, we have the sharks. We have a shark from Microsoft, Vishak, sitting right there. He's a Microsoft principal engineer and works on vision and imaging. We have a shark from Airbus, sitting right there. In the team that also is hosting the next IEEE Joint Communication and Sensing Symposium in, I think, end of January next year at the Airbus campus. So anybody that wants to join that symposium and have a in-depth view of the campus and the stuff that's going on there and the Hyper Loop and Airbus campus, you want to join the IEEE JCNS and talk to Markus. We have another scout, Richie from ZTE. Richie is sitting right there. And so here we are. He's a senior IEEE member and he's responsible for long-term research at ZTE. We have another shark, that is Rachel. Rachel is here. She is from Futurewei, from the US. And she's IEEE Fellow Director Optical Access at Futurewei. And finally, we have Sebastian. He is another shark, shark number 5 from Interdigital. And he forgot to wear his hat today. Sorry. Otherwise, it would be so easy to recognize you, man. Next time you have to wear your hat. Well, the same jacket. Okay, the same jacket. Well, if you work for Interdigital, you're so poor you can only pay for one single jacket. He has 18 years of experience. He's in standardization, 6G, 5G, 4G, whatever all. So he's been an old 3GPP kind of person and IETF related topics as well. Then we have an industry advisory group, and these are the people that actually support this activity. They do the down selection of the 6 presentations that we're going to have today. Sometimes one member of the industry advisory group is also on the committee sitting here. Rachel, it's you this time. Thank you. Therefore, this is great. We also want to thank the whole industry collaboration and loyalty program members of IEEE ComSoc, because this whole thing, of course, is possible due to the, nice help from tier 1 companions, we can say, I mean, members of the corporate outreach program, but I call them companions, Huawei and Nokia. The tier 2 is Ericsson, Keysight, MathWorks, and Qualcomm. And tier 3 is China Mobile, Tsinghua Telecom, Ciena, Cisco, Coherent, Intel, L3 Harris, MediaTek, NTT, Rohde, Schwarz, Samsung, Semtech, TII, Viavi, and Vodafone, the company that also supports my research. So with this, I think we're ready to go. We are, thank God, we're ahead of time. And remember, smile, you're on camera. This is going to be videotaped and uploaded, and everybody's going to click this, everybody's going to look at this. So if you don't get the feedback here right now, it might come 2-3 weeks later, because all your fantastic ideas you're going to pitch now are going to be ready for presentation on the web, and people do look at that, like that, have different comments, and this is also very valuable feedback for you. So with this, let's get started. And our first pitch is from the University of Pisa. Yes, Luca from Pisa. I have many friends that are professors in Pisa. Their first name is always Luca. So it's great to have you here, Luca. Yet another Luca. It's about semantic communication framework for deepfake voice detection. And Luca, the stage is yours. And as soon as you're up here, the clock is going to be ticking.
So, hi everyone. My name is Luca Borgianni. I'm a postdoc researcher at University of Pisa, and I'm affiliate researcher at Stanford University. And I would like to imagine a world where you cannot rely anymore on what you are listening during a phone call or during a video call. And look at these headlines. And in 2026, it's not more imagination. We are already there. And it's not like a joke, because probably you read about this news about CEO scanned because of deep fake voice detection, or, for example, finance workers that pays out 25 millions after a video call with deep fake voice. But it's not only for politicians or managers, but it also could be for your mother or your grandma. And according to recently reports, in 2027, so in 1 year, we expect to have around 40 billion AI fraud losses. So it's a real global crisis, and also the increasing rate of this problem is much higher than classic phishing. So you can see that the expected rate of annual fraud growth is much higher respect to classic phishing. But why is so easy? 3 seconds is all it takes. Because there are a lot of tools nowadays that can clone your voice with just 3 seconds of your voice. And you don't need to be a top engineer or a technician. You can use zero-cost tools that most of them are free, and you don't need any skills. And moreover, the level of this cloned voice is very, very high, and every day they are better and better. But why today current defenses fail? Basically for 3 main reasons. The first one is that most of the implemented solutions are based on acoustic analysis. For example, they analyze the frequency or the spectrum on some artifacts in the audio. Another problem is compression loss. You know that, for example, if you use a network like voice over IP or other network compressions, some of the acoustic footprints of watermarks are cancelled. And lastly, latency lag. There are a lot of tools that can detect clone voice, but offline, because they rely on heavy detection mechanism. And so we want this in real time, and that is working on the network. So what is our solution? Our solution is to move towards what the voice sound to what's the voice meaning is it. So we want to move from audio to embeddings. So for example, imagine that every conversation can be categorized in different clusters in a semantic space. So if you have a conversation about a business conversation, you have a cluster. If you have like a conversation between different friends, you will have another cluster. And scam has a specific high-risk region in which we are able to map this in real time. So the framework architecture that we are implementing is basically done with 3 layers. The first one is semantic extraction. So we are using some large language model to extract the semantic meanings of the conversation. The second step, the second layer, is metadata integration. So, okay, we said that we will use semantic extraction, but we will use in parallel with available metadata, such as acoustic fingerprint metadata or environmental noise. And lastly, we want to have an adaptive defense. So we want that this mechanism is able to adapt to different quality of service network or different signal-to-noise ratio. And we want that this is resilient also in codec compression, and basically another main problem, last but not least, is privacy. Instead of analyzing the voice and saving the voice, we want to save the embeddings and the meaning of the conversation. But why now? Because AI fraud detection is going so fast, and we have to go faster. And so now we are looking for some research and commercialization patterns in order to improve our research and implement some real-world validation testbed. Yeah, thank you for your attention, and this is me.
You want to go first? Okay. Thank you, Luca. A quick comment and a quick question. On the comment side, I think your proposal is a prime suspect for an SME instrument from the European Commission to kick it off, to see how it can work using the StreamC infrastructures to try it out that the SNSGU funding provides. So great work, and again, the easy funding part for SMEs would be a great vehicle to drive decommunalization would. Now my question is though, you need to have access to all the audio files or the audio streams in order to make the assessment whether or not something is rogue. Meaning you have access to all the audio between humans. What about the continuous and growing concern when it comes to privacy? If I don't know if I'm being recorded, how do I know that your tool versus somebody else's tool is doing the right towards my privacy? Have you thought about that?
Yeah, actually, privacy is an interesting problem, and moreover, yes, actually, what our direction is to say, okay, I don't want to record all the voices, so I don't need your audio file, but the idea is to have endpoint extraction, like we want to extract some, for example, semantic vectors or in a latent space. So we want to convert this audio file to something that is not possible to have a sort of reverse engineering. So the idea is to say, I don't want your audio file, I want for example, the cluster in the semantic space. So this is our idea to avoid this problem.
What are the trade-offs between real-time and accuracy? Because getting it real-time is really important, right?
Yeah.
You have 100 milliseconds there. Is that the benchmark that you're trying to target, or?
Yeah, I think also something that we are thinking of is like having a, let's say, multi-step detection accuracy. I mean, probably we can have something very light that is able to say, to have a detection in a few milliseconds, but the accuracy is low. And so if we have like a warning, we are able to use like a Heaver model to have a higher accuracy. So the idea is to have a multi-step in which in the beginning we have like low accuracy and low latency, and after that we are able like to use 2 or 3 or 10 seconds of the conversation. Maybe you need like 20 seconds to understand if the conversation is actually a scam or not. So yeah, I think there are multi-layer of real time that we want to achieve. Yeah.
So, Luca, you mentioned that this model is adaptive. How adaptive would that be? And then when you accumulate a lot of information, will you need to do retraining or like reprocess the model and to improve it?
Okay, yeah, thank you for the question. Yeah, when I was saying adaptive is, for example, something that we were doing in our research is to analyze how the background noise is like influencing with our initial tools. So when we are talking about adaptive, it's like, okay, we want, for example, to have noise removal in real time, like adapt to the different background noise. And so, yeah, this when I was saying adaptive, for example, from this point of view. So adapt to the specific like use case or the background noise or, for example, the specific technology that is used during the conversation. So the codec, for example, or and regarding the data storage, yes, it's a problem. Our idea is to have everything located like locally. So, for example, if there is a company that wants its own detection tool, we need to preserve all the information locally. Yeah.
Last question. We have 20 seconds left.
So you were saying you achieved more than 99% accuracy. On what type of data did you validate this?
Yeah.
And
we had the first collaboration with a small company in Pisa. And so they were able to give us a data set. And moreover, we also use, let's say, a data set that we created with some LLMs that were like talking each other. So a cluster of LLMs. So these two data sets.
Great. Thank you.
Thank you.
So, did you see how he was fried to pieces? All good. It can be different. Thank you, Luca. The next person is Jorge. He is Marie Curie postdoctoral fellow in Dublin at the University College in Dublin. And the pitch title is, you're going to say, oops, let me do this. Whatever that is.
Yeah. Thank you so much. I'm Jorge Davideot, as said, postdoctoral fellowship at University College Dublin. I work there with the rest of my team, the DNS Research Lab, at cybersecurity topics involving AI, machine learning, intrusion detection mechanisms, and also secure by design architectures, like CMX Safe, which I'm presenting today. And makes a lot of sense in this context where cybersecurity incidents are growing so much, particularly focusing critical infrastructure. This has pushed government and regulatory bodies to push forward Cyber Resilience Act and the NIS2 directive to encourage businesses and organizations to be accountable for their cybersecurity, report the incidents very fast and other responsibilities as well, but also keep their devices updated and the security at the certain levels required. But this is not easy because the security inside the devices is very tied in. So the security of the communications, it gets outdated. You cannot just change that component. You need to sometimes change even the source code of the application so the new security component fits in. And this is particularly difficult when the security API changes. So what we propose as a solution is actually very intuitive, right? We create an independent security module that will transparently secure all communication with proxy mechanisms within the device. And we have developed a secure communication to allow this relationship between these two modules secure enough. And we have successfully patented it. And then we have achieved this end-to-end secure communication path that allows communicating devices with platforms. In a similar fashion, all telephone networks work with virtual circuit switching. And this is the key difference with point-to-point security, that we have in the middle interconnectivity. If we think about VPNs, VLANs, and other kind of security measures that try to secure the perimeter, for instance, we have with CMX Safe very nice fine-grained access control mechanisms that prevent lateral movement and then limit the scope of potential attacks that can come from within the business. And this suggests the first and most obvious use case for this technology, that is reducing the risk in our facilities, in our corporations, by attaching this technology to legacy devices that are already deployed. And this not only allows to secure traffic in-house, but also recertify these legacy systems again as a combination of the old system and the new technology. This can represent a huge reduction in the efforts for compliance with the NIS2 directive, we estimate between 25 and 40%, precisely because no source code requirement is a modular technology, and also it requires very, very low overhead, which expands the possibility of implementing this technology in many use cases. And of course, as well, the capacity of recertifying again legacy systems to the current standards. So the time is now. Why? Not only because of the cybersecurity landscape, it's because the pressure in the regulations now, the fines and penalties are going to become effective in the next couple of years, and the market is huge for this kind of cybersecurity opportunity. It's growing at a 26.8% every year. So we are looking for collaboration, partners for collaboration, and we want to test this technology in the field, not only to prove the cybersecurity properties CMXs have to offer, but also get empirical value of the value creation we can provide by facilitating the NIS 2 compliance. Thank you. Do you have any question?
Thank you for the presentation. So in my company, IoT security is a very important thing. So let's probably have a talk later on. Apart from that, when you say certifiable, what do you mean exactly? Because we have some industry standards that are quite strict on this. Have you tried to certify your system against some of these standards?
Yes, we are following the CESIP certification, which is a recently new standard in Europe that allows certifying your components in IoT environments and then reuse this component within your own products. And there is a mapping for other security certifications already available. So this is the path we are now following. It's not yet certified, but we are working with a laboratory to get that done very, very soon.
Yeah, thanks for the presentation. And I think I like the idea of providing security without having to replacing these legacy equipments. So just one question. So if you introduce this new mechanism or new layer, will it have impact on the data communication, for example, the latency, the communication metrics and performances?
Sorry, I didn't get the question.
So by introducing this new mechanism for security, what impact do you foresee for the real-time data traffic?
We have tested this with with industrial protocols like Goose protocol for a smart grid, and it's like hundreds of nanoseconds. Because once the virtual circuit channels are established, it's extremely fast, and we have tested this with real Goose traffic between different data centers, and it works very well. It works very well. So it has some overhead in the latency, but it's minimum.
Thank you. So maybe just as a food for thought, if you were to commercialize that, and if you were to add a wireless connectivity to your gateway component that basically shields all the IoT devices that are deployed somewhere, there's a concept called residential gateway in 5G, where essentially you have a local area network behind your smart, like your device, right? And this sort of extension, what you are building, could be essentially a product that builds on top of a standard 5G like device standard, and you can essentially sell your gateway using a wireless connectivity without the need to hook up all the sensors that somebody deploys with any wired connectivity. So the internet you need is essentially a 5G connection that comes as part of your device. So as an opportunity, if you were to commercialize this, looking at residential gateway deployments, having a wireless connectivity behind would perhaps boost the applicability of deployment scenarios.
Yes, we can license it as a end user license, so the customer can integrate it as it sees fits. But we also have prepared the infrastructure as a service. So we provide the cloud infrastructure, you get the security module, so your new devices can be developed more easily because you don't have to take consideration of all this security in the communication. You just have our security module that will be updated frequently, and in a streamlined fashion, and we have the cloud infrastructure ready so you can deploy and grow very fast. And if you want to deploy your own cloud or in-house cloud or in-house gateway, you can do it as well. But these are more or less the two commercialization options we have considered so far.
How does this work with existing security frameworks or zero trust frameworks that are already there, like Entra ID or something like that?
Sorry, I didn't get the...
How does this work with existing zero trust frameworks that are already?
Yeah. Yes, we don't claim we get fully zero trust because we are trying to keep the modularity. We operate in the 4 OSI layer, but we take care of the security of the communication. So any semantic related to access a particular variable, a particular piece of data, still relies on the protocol. But the encryption, identity of the device, we guarantee that, and we simplify that from the application. And this allows reducing the frequency updating of the core application as well. We expect that it impacts beneficially in the development and of the solutions.
One last question? Not there? Everybody's happy? Then thank you very much. Thank you. With that, we come to our next speaker, Taraka Heva. Again, an acronym.
Okay. Yes. Thank you. And thank you for this recognition and opportunity. Today I am presenting my postdoctoral research track, which is entitled as XADRA, XAI-driven sustainable security architecture towards model drift resilient AI RAN. So, well, if you take a look on the background, AI RAN is envisioned for autonomous, optimized, and secure wireless connectivity. And AI RAN is defined into 3 key pillars by AI RAN Alliance as AI for RAN, AI on RAN, and AI and RAN. In general terms, AI's intelligence part relies on the machine learning models trained from a large number of data batches, like telemetry information, for gradually improving the model's ability to recognize patterns in automated decision-making tasks. If you focus on the probabilistic principles and background behind AI, the decision-making strength of a machine learning model heavily depends on the statistical correlations and mathematical relationships established between input features and the target classes during the training. Due to natural or adversarial reasons, deviations of these relationships will degrade the model performance, which will be known as model drift. In this research, it will be further divided into data drift and concept drift. The example scenarios emphasize the AI-based slice selection based on the input features of the reference signal received power and latency. Figure 1 reflects the data drift scenarios due to sudden influx of users who are physically closer to the cell tower due to local event like a concert that increases RSRP values, resulting in the requirement of a new decision boundary, which is in green. Figure 2 reflects the adversarial concept drift scenario where the misclassifications of resource request overutilizes the resources, leading to service disruptions for the legitimate users. I would say model drift is a silent failure for AI native systems with dreadful consequences. The training data in production-grade systems retrieved from heterogeneous components of the network like base stations and enterprises or the state entities cannot escape from the adversarial manipulations of training data in modern cyber warfare. The consequences of model drift will be costly with extensive adaptation overheads, including model recovery from the drift impact to the inner layers. The service reliability regression and the QoS degradation and other service disruptions will be significant disadvantages for the service providers in competitive markets. Towards sustainable model drift resilience in AI RAN, early drift detection and lightweight adaptation mechanisms are essential to minimize unnecessary adversarial and recovery overheads, reduce operational cost, reduce carbon footprint, as well as improve resource efficiency for energy-efficient intelligence. In this research, the model drift resilience is distinguished into 2 stages. as drift identification and drift adaptation. First, this research investigates the model drift identification with stream change detection problem solving approach while leveraging explainable AI for feature space identification and insightful adaptation. From the research publications, this research has promising results with 3 key publications, including 2 conference papers, first authored by me and second authored by me, as well as submitted journal article to IEEE Transactions on Reliability, which is under review. This approach was validated with resource allocation and included detection scenarios using well-known datasets. This research has yielded promising preliminary results with accuracy improvement by 17%, with XAI-driven feature space minimization and reduced training time for intrusion detection. And the second paper reflects cost savings through QoS over-provisioning and under-provisioning prevention and AI-based auto-scaling use cases. In addition, the submitted journal article has promising results on energy savings, which will increase the battery life of edge-integrated systems. And the current funding status is like that. I have secured 8,000 plus euros for research collaboration with Network Security Privacy Research Lab in KAIST, South Korea, and 2 funding proposals are pending. One is to visit and establish MOU with Mason Innovation Labs, Arlington, USA, for experimental evaluation. And the second proposal is the Academy Research Fellowship, which has collaboration support from Northeastern University's leadership position in the AI-RAN Alliance and Michigan University. Yeah, so for collaborations, I would like to collaborate with the industrial partners for future research funding, as well as joint publications and experimental evaluations. And if you have any questions, please.
Thank you. Thank you for the presentation. I want to ask about the drift. So your research is focused on, or the project is focused on, control the drift and adjust that. So you minimize the error and you always adapt to the environmental change. So what's your definition of the drift in your model? And then do you have any threshold to control it? Or can we adaptively define the drift based on, different RANs application? Oh.
So, can you please elaborate?
I want to know how you define drift in your model, and can you control the drift? So different operators RAN may have different requirements or criteria for the drift. Can we adapt to different applications?
Yeah. So here, if we go through the published articles, I think we were more specific towards the different use cases. For example, here we defined the drift in the first publication as the classification accuracy degradation of the intrusion detection. So we simulated using Gaussian noise and identified that the potential drift will lead to identify the denial of service attack that will increase the false negatives and reduce the, even increase the risk of the network for being compromised. So that is the first use case. And the second use case is the auto scaling. And in the auto scaling, we have identified that the scaling decisions that will lead to over provisioning as well as under provisioning of the resources that will eventually end up with cost increases. So these are the 2 different scenarios. For the moment, we have evaluated and published in the results. Even the journal article also same. So we validated with these particular data sets for multi-class classification in the attack identification. So these 2 scenarios are mainly from the intrusion detection, because I'm working for the Network Security and Trust Privacy Research Group in University of Oulu. So this is mainly within our team's focus. But I'm very happy to extend this particular concept as well as the approach.
Short answer.
Yeah, towards the radio access networks. Yes, thank you.
Next question.
So you've shown us, hello, test. Hi, okay. So you've shown us the research results here, but for industrialization, you'll also need more. So you will need something like an API that you can use. You need a software that is ready deployable. You need a data format by which you can directly inject our data. How far is your implementation status in
Yeah,
this
so
regard?
here we proposed in the last submitted journal article, transaction article, we have proposed a service architecture. So that will be ideally, we can say, can be deployed as a Docker container, for example. And here we have addressed the privacy problem for when we consider the scenarios where the data has to be monitored against drifts and how to handle this privacy part when we deploy this drift detection as a service.
But have you implemented in a way that
Yeah, we have done
readily
some.
used?
We have done some simulations. That means simulated environment. We have implemented because we are more focused on the novelty of the logic, so not on the experimental part, or even that. That's why we need some collaboration for the field trials. So even deploying on the real test-bed environment.
Okay, thanks.
Yeah.
Thank you. Just have a small recommendation. So on the last slide where you put down the next steps, basically, there was quite a lot of emphasis on publications. So while I understand the problem, the challenge is though, is it really a problem for operators? Where the models that are deployed, they have been well trained, well tested, and they will not basically run artificial models that come from third parties, untested, untrusted.
Yeah.
So if the problem is really towards RAN, which is a fully controlled environment by operators, I would recommend to focus less on publications and more on having this sort of conversation and perhaps get into collaborative projects where you get through NDAs, you get access to information that you're not publicly allowed to talk about, but you can get the insights where is it really a problem for the telco industry?
Yeah.
But
I appreciate, and I think that's why I have proposed for this, applied for this proposal pitch session. So I think that's quite good. Thank you.
Sorry.
Time is up. Thanks. Thank you once again. And we come to our fourth pitch, which is by Trasos Oikonomou. Oh, sorry. Yes. There you go. Okay.
Okay, before we dive in, I would like to share a concern with you. Ultra-high order modulation promises more bits per hertz. But what if the receiver is the bottleneck? Good afternoon, everyone. My name is Trasos Oikonomou. I'm a PhD candidate at Aristotle University of Thessaloniki, and today I will present you superconstellations, a hardware-aware approach for making ultra-high order modulation practical. The idea starts from a following observation. When the signal space gets crowded, the receiver must learn to see more clearly. This research comes from the Wireless Communication and Information Processing Group. Our expertise is in modulation, detection, and impairment-aware designs. The group has a strong research track record under the leadership of its founder, Professor George Karagiannidis. The industry trend is clear. We see 1K QAM in deployed systems such as Wi-Fi 6. We see 4K QAM in Wi-Fi 7. We see 8K QAM in commercial point-to-point radios, and we see 16K QAM and Super QAM concepts being discussed for future 6G systems. The logic behind this transition is simple. More bits per hertz, higher data rates. But this is also where the challenge appears. Each new modulation order packs more bits per symbol until even tiny hardware distortions become the system-level limits. The receiver challenge becomes clearer here. On the left, at conventional modulation order, hardware distortions are present, but the symbols are far enough to remain separable. On the right, at ultra-high order modulation, the same impairments are present, but the spacing between the symbols is smaller. So the distorted received symbol now spreads into neighboring symbol locations, creating overlaps. In other words, the impairments were always there. The margin is what disappeared. So ultra-high order modulation requires receivers that understand the hardware reality. Our answer is PAD-D, the phase and amplitude distortion detector. Instead of treating impairments as afterthoughts, we make them part of the receiver's intelligence. PAD-D models amplitude and phase distortions. It weights decision using hardware statistics. It operates in the polar domain, and it is designed for receiver-side integration into existing PHY layer architectures, including OFDM. The result is a different detection philosophy. From idealized noise assumptions to a detector grounded in real hardware behavior. Once the receiver becomes hardware aware, the next step is to design optimal constellations. On the left, we have QAM, conventional QAM, and on the right, we have optimized constellation formats based on PAD-D, designed with hardware impairments in mind. As a result, we do not only detect differently, we design the signal space differently. The impact of PAD-D is up to 10 times lower error floor compared to conventional Euclidean detection under hardware statistics. Moreover, PAD-D can improve reliability without requiring a full system redesign, since it is receiver-side and algorithmic. Now that the theoretical foundations are established, the next step is validation in real systems. We are looking for partners in 3 directions. First, to validate PAD-D with real RF impairments profiles. Second, to benchmark it against practical receiver chains. And third, to explore how PAD-D could fit in future communication systems. Ultra-high order modulation is coming, but making it practical requires receivers and constellations that are hardware impairment designed. Thank you very much for your time.
Yeah, thanks a lot for the presentation, and I like the flavor of it, that you look at the standards right now, nowadays, and trying to go 1 or 2 steps beyond. Just a question about, as you said, you think that the receiver is a bottleneck, right? And if you look at the really high data rates normally happen in downlink. So the receiver is the user device. And then how would you try to evaluate, for example, the complexity and the modulation latency on the user device side? Because normally we assume that the user is constrained by its power consumption. And so normally we don't introduce very high complexity algorithms. So how do you?
Thank you very much for your question. I have to say that the proposed detector is a maximum likelihood detection metric like the conventional Euclidean distance detectors. So that's why I told you that it is receiver side and algorithmic. So the complexity is not increased. We just dive into the signal formation. We adapt, we rethink the way we detect, and we try to improve, to degrade the symbol error rate so that super constellations, ultra high order constellations can be made practical.
Thank you for the presentation. I like the idea of changing the sort and then design that from receiver's perspective. So my question would be, when you transmit the signal, before the receiver can actually function, do you need to do several rounds of coordination or feedback and to control the signal to coordinate with that receiver?
Well, thank you for your question. First, we need in the transmitter side, as I show you, you have to change a little bit the constellation format and remove from the QAM to a more complex or a more sophisticated constellation design. Now, in the receiver, our detector needs some CSI in terms of what are the variances of the distortions, what are the variances of the amplitude distortion and the phase distortions, but not an exact value of that distortions. Since they are residual, we model them using some distributions, and I think that these are the only things that the detector, the receiver, must know on contrary with the existing Euclidean distance architectures, that they don't need to keep track of these two very important distortions.
How does this? How do you evaluate how do you measure the quality of experience improvement? You're in the quality of service space, right?
We followed the literature on the residual distributions after sophisticated compensators. And we used these models. They are accurate for tiny hardware distortions that are have detrimental effects in higher order constellations. And we managed to derive a closed 4 ml maximum likelihood detection metric. And then we tested in simulations, in MATLAB simulations, and we have found out that the results are very promising in terms of degrading the symbol error probability and doing the system by far more reliable.
One last question?
Well, maybe the same question as to the speaker before. You said you have simulated it, right? Do you have any SDR implementations or similar with real hardware measurements?
Actually, this is what for what I came here. We need to validate these simulations in real systems with measuring and modeling accurately, more accurately than in the literature, the hardware distortions, maybe from an SDR testbed with a...
Good.
And,
yes,
okay.
And the guy from the company is right there.
Hope to talk after the session.
Good.
Thank you. Thank you very much.
Thanks a lot. So with this, we come to our next pitch, which is given by Ehsan Shebani. Ehsan, the floor is yours.
Hello, everyone. Thank you for this opportunity. First, let me apologize because the person who is supposed to be presenting this could not make it here. So they asked the AI guy to be here. So he's the communication protocol specialist that we have. But nevertheless, we are partnering at university and also at a startup company. As you can see, we are trying to come up with a cybersecurity methodology for satellite and non-terrestrial networks. So the real problem is the challenge here is that the global exposure to cybersecurity is growing at a high speed, especially non-terrestrial networks, which are just starting to develop in LEO, MEO, and GEO type satellites that are being eavesdropped or intercepted. The critical traffic also relates to military applications, which are very important to ISR and to emergency signaling systems, communications, and basically the NTN infrastructure. And on the other hand, the threats are becoming very sophisticated. You know, there are newer threats, AI-based type, and so on, which are becoming more sophisticated, faster, and more effective. And of course, most of the available technologies are static security algorithms, which are not adaptive, which are not dynamic, and cannot adapt to the environment. So summing it all up, the current physical layer security system is suffering from static risk assumptions, from uniform protection levels, the no threat adaptation, and also scalability gaps. And therefore, we are proposing a framework for the NTN and mission prioritized PLS systems. Here, the idea is to have a mission risk engine where we can basically designate specific applications to the particular mission, and also have a threat probability modeling, which is deriving the probability of different aspects of the threats, as well as the adaptive PLS control, which minimizes the secrecy of the applications. So basically here we are trying to, rather than the static service tiers, we are trying to stick to resources that follow mission priorities. We have developed some mathematical foundation for this. We have actually published this in IEEE journals, and basically there are three important aspects to this. One of them is the secrecy rate modeling. The other one is the non-normalized risk modeling, and finally there is the optimization objectives of the model. And the target applications, as you can see, along with the architecture of the system, consists of software-defined satellite payloads, which are mission-aware, and also the real-time risk scoring, and also the adaptive layer for the PLS, which basically together they can give you this new proposed algorithm that we have. The applications for this are military applications, satellite communication, and tactical LEO. It can also help with the ISR links and emergency response systems, maritime and broadband communication, and also a space-based IoT. And of course, the motivation is a $9 billion tag, as well as adaptation to 3GPP. There's a lot of potential for IP here, and of course, there's dual use value to it. Here are some of the publications that are relevant and validate our work. And here are some information if you want to get in touch with us. Thank you.
Thank you for the presentation.
Thank you.
So you were mentioning that to implement this idea, you would need sophisticated components on a satellite, for example.
Yes.
So far, most satellites still use the bent pipe principle, which means they don't have an FPGA on board. If it is on board, it is highly limited because you have very little space. There are many functions you want to put on. So what will the impact, or what is the complexity on the hardware to implement this?
Well, our complexity at this point is FPGA, and of course, we haven't practically implemented this, so that is one of the reasons we need collaboration and funding.
Okay.
Yeah, thank you. So I did see in the last slide the attempt to engage more of a 3GPP/ETSI you're mentioning there to gain the insights. So given that you're after a framework and basically it's the integration, the understanding what is available at satellites, what's available, what's feasible to change, I would almost recommend not targeting 3GPPs directly, because what you're asking for is some sort of pre-standards insights. So ETSI there is a better forum, given that you're in North America. Perhaps the Next-G Alliance as a first contact point would be a great vehicle to get the insights you need to push your idea forward. And then once you're there, then certainly, contributing to white papers to get your ideas out would be, I think, more reasonable than targeting 3GPP as the next step immediately.
Thank you for that.
Yeah, just to say, can we go back to the slide where we mentioned 3GPP and ETSI? I would like to check. Yeah.
Maybe I add one question here. That is, if you're talking about physical air security in a line of sight scenario, how can you do that?
That's probably a good question for my partner, but if you want, I can email you back with the same answer.
And in your beginning slide, you mentioned LEO, MEO, and GEO. Does your proposal cover all of those scenarios for the physical layer security?
Yes, basically in theory they do. But of course we are waiting to see what comes out of practical aspects.
Well, good. Then thanks once again.
Thank you.
And we come to the last presentation by Abdul Hamid. And he's going to be talking about something I can actually pronounce, which is from cell-based to cell-free. There you go.
Thank you very much. Good afternoon, everyone. I'm Abdul Hamid. I'm a Royal Academy of Engineering Enterprise Fellow at the University of York. And today I'll be showing you how we're addressing one of the fundamental gaps in wireless reliability. So 5G has clearly won on scale, but it has not yet earned trust, especially when enterprise operations depend on it. So rollout happened, traffic is growing, coverage is expanding, and connections are scaling across Europe and throughout the world. However, enterprises are telling us something very different. So they're struggling with complexity, they're struggling with reliability, but more importantly, they don't fully trust wireless when it relates to their core operations. So we believe that the next value pool is not more rollout, it's actually a performance they can trust. We already see how the market is responding and evolving. Nearly 2,000 organizations have already deployed private networks. Manufacturing leads because that's where failure and downtime is most expensive. For example, Jaguar Land Rover here in the UK published that the cost of network downtime is costing them $55,000 per minute. And that's for a single factory. So these buyers, they're not buying bandwidth. They're buying control over performance, security, and operations. But here's the core problem. Even with private networks, failures still happen. And they don't start in the core network, they start at the radio layer in industrial environments. So metals, movement, interference are constantly changing this environment. And when that happens, handover becomes interruption, and interruption halts automation or other industrial use cases. So the real question is, can we prevent failure before it happens? Traditional cellular networks are optimized for capacity and coverage, not for reliability and resilience. One node per area means one point of failure, and a single failure can halt an entire operation, especially if it's safety or mission critical. We believe that the cell-free architecture is the solution, particularly for localized private networks, because each device is served by multiple access points or ready units simultaneously, so one failure never stops them. We're not proposing the cell-free concept. Cell-free has been there for like 10 years now. But what we are doing is we're making it happen. We've built the UK's first all-RAN-based cell-free testbed to demonstrate the concept. And what we're currently doing is having a fully compliant 3GPP cell-free testbed in our lab, which means that commercial off-the-shelf 5G-enabled devices can directly connect to it. In essence, it's a network-side technology that's completely transparent to commercial devices. We're a team of researchers, innovators, backed by industrial leaders as well, with more than 100 years of combined wireless systems experience. And we've taken the technology out of the lab into a real industrial environment. We're currently running a co-funded trial with the Port of Tyne in the northeast of England with interesting results. The key takeaway from this slide is that when it comes to industrial reliability sensitive use cases, handover is one of the major challenges. And in a cell-free based private network, handover is completely eliminated. Finally, we believe that the next era of private 5G and 6G is not to scale further, but to make it dependable, moving from connectivity to continuity. If this is something you or your R&D teams are interested in or working on, I'd be happy to have a chat afterwards. Thank you.
Thank you for the presentation. I probably have more of a comment than a question, which is if you really want to achieve, for example, 5 nines, you will also need to ensure that all of the components in the core or in the back end are also secure, which often means you need to duplicate those as well, right? I mean, obviously, the space station is one key failure point. But there are many other different failure modes as well that also need to be tested and done.
Yeah, thank you for that. Specifically, we address the lower layer, so the physical layer and the MAC layer, but I completely agree with your remarks exactly. The system will have to be resilient all the way through back to the core and perhaps even beyond. Thank you.
Yeah, thanks for the presentation. So I see in one slide you mentioned that your solution is compatible with 3GPP standards.
That's correct.
So yeah, maybe somewhere I saw that. Yeah, okay. So does it mean that you also use the multi-TRP conf transmission solutions already defined by 3GPP, or what do you mean by 3GPP compliant?
So the basic premise of this is that it's compatible with commercial off-the-shelf devices. So that doesn't mean we can incorporate everything on the 3GPP standards. So what we're casting this is from the perspective of the UE, because any modifications on the UE side, like other testbeds out there, research testbeds, would actually extend the route to market. So this was a main or a major design constraint, which is to make it compatible with currently available commercial off-the-shelf devices.
Okay, now I see. So, but I think there will be some technical issues to fix. For example, if you're talking about off-the-shelf UEs, and they don't follow this cell-free behavior, right? For example, they connect to a cell, they search for the PCI, but here you will have multiple radio heads. So how do you make the UE believe that it's still following the 3GPP manner? So for example, do you broadcast the same PCI, or do you...
Thank you for that. This is exactly the innovation, and that's why we listed that. It's actually from the UE perspective, it's still attached to a single logical cell. So it's fully UE transparent, and that's one of the other main major design constraints, which is because there are no standards for cell-free out there. We're hoping for them to come with 6G, but that's actually one of the main advantages that we have, is that we make the value proposition of the cell-free completely transparent to the receiver side. So it's a purely network side innovation rather than a UE side innovation.
Thank you. Just a question. Why do you so adamantly focus on private networks? I mean, I don't quite understand why you're limiting yourself to that, because, I mean, the real money, if you look at private network deployments and who is paying for this compared to the general public, where the operator is really getting the money. I mean, if this can work in any deployment, why do you restrict yourself to private networks? I don't get that.
Thank you for that. And I just want to highlight that in a recent conversation with a system integrator and neutral host, they exactly raised that question. So there are two reasons. So this is our beachhead. We're entering through private 5G, but the immediate limitation is actually the compute power. Because in cell-free, you centralize processing at something called DU within the RAN. It's disaggregated RAN, right? So the heavy lifting is done by the DU. And the more you scale the network, right, hundreds and hundreds of RUs, then you'd end up having a supercomputer, which is not a great idea for a DU.
Well, I mean, then it's up to the users to pay for this, to make it scalable. So whoever's willing to pay for this, then the operator's willing to deploy. Then, you know.
It's perfectly reasonable. Yeah. Thank you for that. You. Yeah, but immediately, and the test bed that we've built is built around the private 5G network. What we wanted to do is actually penetrate the market through that and then see how we can scale. But it's definitely on our roadmap. Thank you for that. Yeah.
So I just have a question on how do you plan to expose the signals to the application layer and measure the impact on the application layer, like latency or...
Could you please elaborate on that? Are you asking whether the introduction of a cell-free processing chain at the MAC and the PHY introduces latency? It definitely does, but with smart signal processing and software implementation practices, it's minimal. We're currently scaling from 4 RUs to 8, and we've been able to do that.
Whatever minimal is. Okay, I still would have a question. How does this fit into the concept of coordinated multipoint? Because that has been standardized. But we call it shots here. Thank you all for all the speakers. So let's see, here we are. I want to thank again all pitchers for pitching. We lost one pitcher on the way. He has to give a presentation in the session. So don't worry, he didn't run away because he was so frustrated. There was some scheduling. There's always a little bit of scheduling issue at these kind of conferences. So that's too complex to be able to not have scheduling conflicts. So this way, I want to thank the presenters, the pitchers. I want to thank, of course, the sharks. And we're going to the next stage. The next stage is every shark is going to have a table back there. They're going to be standing back there. And the pitchers have a chance to go ring around the rosy from shark to shark. And again, have one-on-one in-depth question and answers and whatever all right after this. I just want to comment. I enjoyed the presentations a lot. I did not enjoy the PowerPoint layout of most presentations. I would have killed my PhD students with these kind of slides, honestly, with the font size of like this. So this is something maybe we should improve next time, that we actually have to enforce that the pitchers send us the slides in advance so we don't have these kind of things. The other thing I noticed is our sharks are sitting too comfortably in those cozy chairs. I think we need to get them raised up a bit in some more uncomfortable high chair so that they are also more uncomfortable with their questions. And any other comments that you want to make, please send them to us, give us feedback, because this is the first time This is the first time we try this out at ICC. It's the third time we do it at a ComSoc conference. We did it last year at GlobeCom in Kuala Lumpur, and before that at MICOM. So therefore, it's a trial thing that we're slowly getting there, but I think it's a lot of fun. And so now is the time for the sharks to move over there to the shark tables, and you, the pitchers, and we'll do sort of ring around the rosy. We'll clap the hands and tell, move on, move on, move on. And anybody of the audience that wants to sort of listen in onto one of those sharks and the shark tables, feel free to do so. There is still some space next to the shark table. No, that's a private session. Oh, sorry, I got that message wrong. It's super private. You're not allowed to eavesdrop. Don't put any microphone pointing to that. That would be mean, evidently. Okay, this is private one-on-one, just the company talking to the pitcher. With this, I want to thank you all and see you again at the next pitch session at MICOM in Sardinia. Yeah, Medicom in Sardinia, and then at GlobeCom next year, not this year, nearly next year in Macau. So thank you all.